Question 1. The assessment process reveals that a critical DB2 one database on a Linux production server has become unresponsive due to an unexpected system crash. The last successful full backup was completed 24 hours ago, and incremental backups have been performed hourly since then. The DBA needs to restore the database to a point in time as close as possible to the crash, minimizing downtime and data loss, while adhering to established operational guidelines for data recovery. Which of the following actions represents the most professional and compliant approach to restoring the database? Option A. Restore the database from the last full backup, and then immediately bring the database online without applying incremental backups or performing a roll forward, prioritizing speed over data completeness. Option B. Use the most recent incremental backup as the primary restore source, bypassing the full backup entirely to save time. Option C. Initiate a restore operation using the last full backup, and then apply all subsequent incremental backups in chronological order, followed by a database roll forward to the most recent transaction log file before the crash. Option D. Attempt to manually reconstruct the lost data by querying other accessible databases and application logs, as this might be faster than a full restore. Correct answer is C. Initiate a restore operation using the last full backup, and then apply all subsequent incremental backups in chronological order, followed by a database roll forward to the most recent transaction log file before the crash. Explanation. This scenario presents a professional challenge due to the critical nature of data integrity and availability in a production DB2 environment. The DBA must balance the need for immediate problem resolution with the imperative to adhere to established operational procedures and regulatory compliance, particularly concerning data backup and recovery. The potential for data loss or corruption, coupled with the risk of unauthorized access or modification, necessitates a methodical and well-documented approach. The correct approach represents best professional practice because it prioritizes a controlled and auditable recovery process. By utilizing a recent, verified backup and following documented recovery procedures, the DBA ensures that the system is restored to a known good state. This aligns with industry best practices for disaster recovery and business continuity, which are often implicitly or explicitly mandated by regulatory frameworks governing data management and security. The emphasis on verification and documentation provides an audit trail, crucial for demonstrating compliance and for post-incident analysis. An incorrect approach that bypasses standard backup and recovery protocols, such as attempting to manually reconstruct data or using an unverified, potentially incomplete backup, poses significant regulatory and ethical failures. It risks data loss or corruption, violating data integrity principles. Furthermore, it bypasses established security controls and audit trails, potentially leading to unauthorized data access or modification, which could contravene data privacy regulations. Such actions demonstrate a disregard for established operational procedures and a failure to uphold the DBA's responsibility to protect organizational data. Another incorrect approach, such as restoring from a backup without proper validation or testing, also carries risks. While seemingly expedient, it could lead to the restoration of corrupted data or a system that is not fully functional, causing further disruption and potential data loss. This failure to adequately test the recovery process can be seen as a breach of professional duty to ensure system reliability and data integrity. The professional decision-making process for similar situations should involve a clear understanding of the organization's disaster recovery plan and data retention policies. It requires assessing the severity of the incident, identifying the most recent valid backup, and executing the recovery process in a controlled, documented manner. If the standard procedures are insufficient or compromised, the DBA should escalate the issue to management and relevant stakeholders, seeking guidance and approval for any deviation from established protocols, ensuring transparency and accountability throughout the recovery process. Question 2. Assessment of the most appropriate methodology for a DB2 one advanced DBA on Linux to address critical performance degradation in a production financial database, considering U.S. regulatory compliance for data integrity and auditability. Option A. Conduct thorough analysis of performance metrics, test proposed tuning solutions in a representative staging environment, and implement changes during a scheduled maintenance window with a documented rollback plan. Option B. Implement changes during a scheduled maintenance window, but skip the staging environment testing to save time. Option C. Immediately apply performance tuning scripts directly to the production database during peak hours to resolve the issue as quickly as possible. Option D. Execute performance tuning commands based on anecdotal evidence of problematic queries, without prior testing or understanding of their full impact. The correct answer is A. Conduct thorough analysis of performance metrics, test proposed tuning solutions in a representative staging environment, and implement changes during a scheduled maintenance window with a documented rollback plan. Explanation. Scenario analysis. This scenario presents a professional challenge for a DB2 advanced DBA for Linux, UNIX, and Windows in a regulated financial services environment. The core challenge lies in balancing the immediate need for performance tuning with the stringent requirements of data integrity, auditability, and regulatory compliance, specifically within the context of U.S. financial regulations. The DBA must make critical decisions about data manipulation that could have significant downstream impacts on reporting, compliance, and the overall stability of the database. The pressure to resolve performance issues quickly, coupled with the potential for unintended data corruption or noncompliance, necessitates a meticulous and risk-aware approach. Correct approach analysis. The correct approach involves a phased, controlled, and documented methodology. This begins with thorough analysis and understanding of the performance bottleneck using DB2 diagnostic tools and system monitoring. Crucially, any proposed changes must be tested in a non-production environment that mirrors the production setup as closely as possible. This includes replicating data volumes, configurations, and workloads. The testing phase is paramount for identifying potential side effects, performance regressions, or data integrity issues before impacting live operations. Implementing changes during a scheduled maintenance window with a rollback plan in place further mitigates risk. Post-implementation monitoring and validation confirm the effectiveness of the changes and ensure no adverse effects. This approach aligns with best practices for database management in regulated industries, emphasizing data integrity, system stability, and auditability, which are implicitly required by regulations like those overseen by the SEC and FINRA, focusing on the accuracy and security of financial data. Incorrect approach is analysis. Implementing performance tuning changes directly in the production environment without prior testing in a staging environment is a significant regulatory and ethical failure. This bypasses critical validation steps, increasing the risk of data corruption, system downtime, or incorrect financial reporting. Such actions could violate regulations requiring data accuracy and system integrity, potentially leading to severe penalties and reputational damage. For example, the Sarbanes-Oxley Act, SOX, mandates internal controls over financial reporting, and uncontrolled database modifications directly undermine these controls. Applying performance tuning scripts or commands without understanding their precise impact on data structures and transactional integrity is another critical failure. This demonstrates a lack of due diligence and a disregard for data governance principles. Unforeseen consequences, such as deadlocks, data inconsistencies, or performance degradation in other areas, could arise, jeopardizing the reliability of financial data. This directly contravenes the principles of data stewardship and the regulatory expectations for maintaining accurate and reliable financial records. Performing changes during peak business hours without a scheduled maintenance window or a rollback strategy introduces unacceptable risk. This can lead to immediate disruption of critical financial operations, impacting trading, customer transactions, and regulatory reporting. The lack of a rollback plan means that if issues arise, recovery could be prolonged and complex, further exacerbating the problem and potentially leading to extended periods of noncompliance. Regulatory bodies expect financial institutions to maintain operational resilience and minimize disruptions to critical services. Professional reasoning. Professionals in this role must adopt a risk-based decision-making framework. This involves 1. Risk identification, recognizing potential threats to data integrity, system availability, and regulatory compliance. 2. Impact assessment, evaluating the potential consequences of any proposed action on business operations and regulatory adherence. 3. Mitigation planning, developing strategies to reduce identified risks, including testing, phased rollouts, and rollback procedures. 4. Documentation and communication, maintaining detailed records of all actions, decisions, and their justifications, and communicating effectively with stakeholders. 5. Adherence to policy and regulation, ensuring all actions are compliant with internal policies and external regulatory requirements. This systematic approach ensures that performance improvements are achieved responsibly, safeguarding the integrity of the database and the organization's compliance posture. Question 3. Comparative studies suggest that when a DB2 one database on a Linux system experiences a sudden and significant performance degradation impacting multiple applications, a DBA must act decisively yet cautiously. Which of the following diagnostic and resolution strategies best aligns with professional best practices for maintaining system integrity and operational continuity? Option A. Randomly terminate active application processes and long-running queries that appear to be consuming significant resources, hoping to free up system capacity. Option B. Immediately increase the size of the buffer pool and adjust lock timeout settings to their maximum values to alleviate potential resource contention. Option C. Revert the database configuration to a previous known stable state without investigating the current performance metrics or recent changes. Option D. Systematically analyze DB2 snapshot monitors, event monitors, and diagnostic logs to identify specific queries, application processes, or resource bottlenecks contributing to the performance issue before proposing any changes. The correct answer is B. Immediately increase the size of the buffer pool and adjust lock timeout settings to their maximum values to alleviate potential resource contention. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, balancing performance optimization with data integrity and compliance requirements in a production environment. Core difficulty lies in identifying the root cause of performance degradation, without introducing further instability or violating data access policies. The DBA must navigate potential conflicts between immediate performance needs and long-term system health, all while adhering to strict operational guidelines. The pressure to resolve the issue quickly, coupled with the potential impact on business operations, necessitates a methodical and well-justified approach. Correct approach analysis. The correct approach involves a systematic, non-intrusive diagnostic process that prioritizes understanding the current state before implementing changes. This aligns with best professional practices by minimizing risk and ensuring that any subsequent actions are based on concrete evidence. Specifically, utilizing DB2 built-in monitoring tools, e.g., snapshot monitors, event monitors, and diagnostic logs to gather performance metrics and identify bottlenecks is crucial. Analyzing these metrics to pinpoint specific queries, application processes, or system resource contention that are contributing to the slowdown is the logical first step. This evidence-based methodology ensures that proposed solutions directly address the identified problems, thereby upholding data integrity and system stability. This approach is implicitly supported by general IT best practices for change management and incident response, which emphasize thorough investigation before remediation. Incorrect approaches analysis. Implementing immediate, broad-stroke changes without proper diagnosis is professionally unacceptable and carries significant regulatory and ethical risks. For instance, indiscriminately increasing buffer pool sizes or altering lock timeouts without understanding the underlying cause can lead to resource exhaustion, deadlocks, or data corruption. Such actions would violate the principle of least privilege and could be seen as negligent if they negatively impact system stability or data integrity. Furthermore, making significant configuration changes without proper change control procedures or testing would contravene standard operational guidelines and potentially violate internal compliance policies designed to ensure system reliability and security. Randomly terminating processes or queries without identifying their impact could disrupt critical business operations and lead to data loss, a severe ethical and potentially legal failure. Professional reasoning. Professionals should adopt a structured incident response framework. This involves 1. Incident identification and logging, clearly documenting the performance issue. 2. Diagnosis and analysis, utilizing monitoring tools and logs to gather data and identify the root cause. 3. Solution design, developing targeted solutions based on the analysis. 4. Implementation and testing, applying changes in a controlled manner, ideally in a test environment first, and then in production with rollback plans. 5. Verification and monitoring, confirming the issue is resolved and continuing to monitor system performance. This systematic process ensures that decisions are informed, risks are mitigated, and compliance with operational and data integrity standards is maintained. Question 4. The review process indicates a significant degradation in the performance of a critical DB2 one database hosting sensitive customer financial information. The database administrator, DBA, suspects that the performance issues might be related to inefficient query execution or suboptimal indexing. However, given the sensitive nature of the data, the DBA also recognizes the importance of maintaining a robust security posture and adhering to data protection regulations. What is the most appropriate initial course of action for the DBA to take? Option A. Initiate a full database backup and then proceed with aggressive performance tuning by purging old transaction logs and resetting database statistics. Option B. Engage a third-party performance tuning specialist to remotely access the database and implement automated performance optimization scripts. Option C. Review database audit logs and access control configurations to identify any unauthorized access attempts or suspicious activity that might be impacting performance. Option D. Immediately begin analyzing query execution plans and consider adding or modifying indexes to improve query response times. The correct answer is D. Immediately begin analyzing query execution plans and consider adding or modifying indexes to improve query response times. Explanation. Scenario analysis. This scenario presents a professional challenge due to the critical nature of data integrity and the potential for unauthorized access or modification of sensitive financial data within a DB2 database. The DBA is tasked with balancing performance optimization with robust security measures, a common tension in database administration. The challenge lies in identifying the root cause of performance degradation without compromising the security posture or violating data privacy regulations. The need for a systematic, documented, and compliant approach is paramount. Correct approach analysis. The correct approach involves a methodical investigation that prioritizes security and compliance. By first reviewing audit logs and access control mechanisms, the DBA can identify any unauthorized or suspicious activity that might be impacting performance. This aligns with best practices for data security and regulatory compliance, which mandate the logging and monitoring of database access and changes. The subsequent analysis of query performance and indexing, while important for optimization, is performed only after ensuring the security of the data. This phased approach ensures that any performance tuning does not inadvertently create security vulnerabilities or mask malicious activity. This adheres to the principles of least privilege and accountability, which are fundamental to data protection frameworks. Incorrect approaches analysis. One incorrect approach involves immediately proceeding with performance tuning without first investigating potential security breaches. This is a significant regulatory and ethical failure because it bypasses critical security controls and audit trails. If unauthorized access or data manipulation is occurring, performance tuning could inadvertently mask this activity or even exacerbate the problem, leading to data corruption or loss. This violates the principle of due diligence in protecting sensitive data. Another incorrect approach is to assume the performance issue is purely technical and to begin making significant schema or configuration changes without consulting security policies or audit logs. This could lead to unintended security vulnerabilities, such as exposing sensitive data through poorly configured access controls or inadvertently disabling essential security features during the tuning process. This demonstrates a lack of adherence to established security protocols and a failure to consider the broader impact of technical changes on data governance. A third incorrect approach is to solely rely on automated performance tuning tools without human oversight or an understanding of the underlying data and its sensitivity. While tools can be helpful, they may not account for specific regulatory requirements or the context of the data. Over-reliance on automation without a security-first mindset can lead to misconfigurations that compromise data integrity or privacy, a direct violation of data protection mandates. Professional reasoning. Professionals facing such a situation should adopt a structured problem-solving framework that prioritizes security and compliance. This involves 1. Understanding the business context and the sensitivity of the data involved. 2. consulting relevant security policies, regulatory requirements, and internal guidelines. 3. Initiating an investigation with a focus on audit trails and access logs to rule out security incidents. 4. Documenting all steps taken and findings. 5. If no security issues are found, then proceeding with performance analysis and tuning, ensuring that all changes are tested and do not introduce new vulnerabilities. 6. Seeking collaboration with security teams and relevant stakeholders throughout the process. Question 5. To address the challenge of a DB2 one database exhibiting signs of data corruption, potentially impacting critical business operations on a Linux system, which recovery strategy best balances data integrity, operational continuity, and auditable procedures? Option A. Continue normal database operations while monitoring for further errors, assuming the corruption is minor and will resolve itself. Option B. Attempt to manually edit the corrupted data files and transaction logs to correct the inconsistencies, then restart the database. Option C. Initiate a DB2 recover command using the most recent valid backup image and all subsequent transaction logs, meticulously documenting each step and verifying the database's consistency post-recovery. Option D. Restore from an older backup image that predates the suspected corruption, accepting the loss of recent transactions to bring the database online quickly. The correct answer is C. Initiate a DB2 recover command using the most recent valid backup image and all subsequent transaction logs, meticulously documenting each step and verifying the database's consistency post-recovery. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, ensuring data integrity and availability while adhering to strict operational guidelines, particularly when dealing with potential data corruption. The core difficulty lies in balancing the immediate need to restore service with the imperative to prevent further data loss or corruption, and to maintain an auditable trail of actions. The pressure to resolve the issue quickly can lead to hasty decisions that bypass established procedures, potentially exacerbating the problem or violating compliance requirements. Correct approach analysis. The correct approach involves a systematic, documented process that prioritizes data integrity and recovery using established tools and procedures. This aligns with best practices for database administration, which emphasize a controlled and verifiable recovery strategy. Specifically, utilizing the DB2 recover command with a consistent backup image and the appropriate log files ensures that the database is restored to a known, good state. This method is auditable, minimizes the risk of introducing further corruption, and adheres to the principle of least privilege and controlled change management, which are implicit in robust IT governance frameworks. The emphasis on documenting each step and verifying the recovery process is crucial for post-incident analysis and compliance audits. Incorrect approaches analysis. An approach that bypasses standard recovery procedures and attempts to manually manipulate data files or logs without proper understanding or tooling is highly problematic. This could involve directly editing log files or attempting to reconstruct data without the integrity checks provided by DB2 recovery mechanisms. Such actions are prone to introducing subtle but critical data corruption that may not be immediately apparent, leading to long-term data integrity issues and potential application failures. Ethically and professionally, this violates the DBA's responsibility to maintain data accuracy and reliability. It also creates an unrecoverable state from an audit perspective, as the actions taken are not part of a standard, verifiable process. Furthermore, attempting to restart the database without a proper recovery can lead to inconsistent states, violating the principle of data consistency. Another incorrect approach might be to restore from an older backup without considering the transaction logs that occurred after that backup. While this might bring the database online quickly, it results in data loss for all transactions committed since the backup was taken. This is a failure to meet the availability and data integrity requirements, as it leads to a loss of recent, potentially critical business data. Professionally, this demonstrates a lack of understanding of recovery point objectives, RPO, and can have significant business and financial consequences. It also fails to adhere to the principle of minimizing data loss during recovery. A third incorrect approach could be to ignore the corruption and continue operating the database. This is fundamentally unacceptable as it directly compromises data integrity and reliability. Operating a corrupted database can lead to unpredictable behavior, incorrect query results, and application failures, all of which have severe business implications. Ethically, a DBA has a duty to report and address data integrity issues promptly. Ignoring such a critical problem is a dereliction of professional duty and can lead to significant reputational damage and legal liabilities if data loss or incorrect data leads to financial or other harm. Professional reasoning. When faced with potential data corruption, a professional DBA must first isolate the problem and prevent further damage. This involves stopping applications from writing to the database and potentially taking the database offline if necessary. The next step is to consult the DB2 error logs and system event logs to understand the nature and extent of the corruption. The decision-making process should then follow a structured recovery plan, prioritizing the use of built-in DB2 recovery tools. This plan should consider the recovery time objective RTO and recovery point objective RPO for the specific database and its associated business criticality. Documentation of all actions, communication with stakeholders, and verification of the recovery process are paramount. This systematic approach ensures data integrity, minimizes downtime, and provides an auditable record of all recovery activities, thereby upholding professional standards and regulatory compliance. Question 6. Market research demonstrates that DB210, one database performance can be significantly impacted by specific query patterns. A critical production database is experiencing intermittent slowdowns attributed to such patterns. As the advanced DBA, you have identified a potential fix involving a parameter change that has shown positive results in a development environment. What is the most professional and risk-mitigated approach to implementing this change in the production environment? Option A. Document the issue and the potential fix, but postpone the implementation indefinitely due to the potential for unforeseen impacts on the production system. Option B. Create a staging environment that closely mirrors the production setup, apply the parameter change there, thoroughly test, and then implement the change in production with a documented rollback procedure. Option C. Apply the parameter change to a subset of the production database instances first to gauge the impact before a full rollout. Option D. Implement the parameter change directly on the production DB2 server during a scheduled maintenance window, with a plan to revert if performance worsens. The correct answer is D. Implement the parameter change directly on the production DB2 server during a scheduled maintenance window, with a plan to revert if performance worsens. Explanation. This scenario presents a professional challenge due to the critical nature of data integrity and performance in a production DB2 environment, coupled with the need to adhere to specific, albeit implied, regulatory frameworks governing data management and system availability. The DBA must balance the immediate need for system stability with the long-term implications of data corruption or performance degradation, all while operating within the operational guidelines and best practices expected of a professional DBA. The challenge is amplified by the potential for unforeseen consequences when making changes to a live system, requiring a methodical and risk-averse approach. The correct approach represents best professional practice because it prioritizes data integrity and system stability through a controlled, phased implementation. This methodology minimizes risk by allowing for verification at each stage. The use of a staging environment that mirrors production, followed by a controlled rollout with rollback capabilities, aligns with industry best practices for change management and disaster recovery. While specific regulations for this exam's jurisdiction, implied to be US-based for DB210, one on Linux/Unix/Windows in a general IT context, are not explicitly detailed, the principles of due diligence, risk mitigation, and maintaining system availability are universally expected and often codified in IT governance frameworks and compliance standards, e.g. SOX if financial data is involved, HIPAA if health data is involved, though these are not explicitly stated as the jurisdiction. The emphasis is on a proactive, risk-managed approach to system upgrades. An incorrect approach that involves directly applying the fix to the production environment without prior testing or a rollback plan represents a significant regulatory and ethical failure. It bypasses fundamental principles of change management and risk assessment. Such an action could lead to data corruption, extended downtime, and potential violation of service-level agreements, SLAs, which could have legal and financial repercussions. Ethically, it demonstrates a disregard for the stability and integrity of the data entrusted to the DBA. Another incorrect approach, such as delaying the fix indefinitely due to fear of impact, also fails professionally. This inaction can lead to continued performance issues or security vulnerabilities, potentially violating compliance requirements related to system maintenance and security patching. It also fails to uphold the DBA's responsibility to maintain an optimal and secure database environment. The professional decision-making process for similar situations should involve a thorough risk assessment, including potential impacts on data integrity, system performance, and business operations. This should be followed by the development of a detailed implementation plan that includes testing in a non-production environment, a phased rollout strategy, and a robust rollback plan. Communication with stakeholders regarding the plan changes and potential impacts is also crucial. The decision should always favor a controlled and verifiable process over expediency, especially when dealing with critical production systems. Question 7. Process analysis reveals that a critical DB2 production environment requires a robust backup and recovery strategy that minimizes downtime and data loss, while also being resource efficient. The current strategy of performing only weekly full backups is proving insufficient due to the high volume of transactions and the need for more granular recovery points. The DBA team is considering alternative approaches to enhance data protection without significantly impacting daily operations. Which of the following approaches best addresses the need for efficient granular data protection and recovery in this DB2 environment? Option A. Increase the frequency of full backups to daily without altering the archive logging configuration. Option B. Perform a full backup once a month and supplement it with daily transaction log backups only. Option C. Implement a daily incremental backup strategy, supplemented by weekly full backups, and ensure archive logging is enabled and properly managed for point-in-time recovery. Option D. Rely solely on transaction log backups, discontinuing all full and incremental backups. The correct answer is C. Implement a daily incremental backup strategy, supplemented by weekly full backups, and ensure archive logging is enabled and properly managed for point-in-time recovery. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, balancing the need for robust data protection and disaster recovery with the operational demands of a high-availability production environment. The core conflict lies in ensuring that backup and recovery strategies are not only technically sound, but also compliant with internal policies and potentially external regulations. Though this specific exam focuses on the technical and operational aspects within the DB2 framework, implying adherence to best practices and vendor guidelines as a form of regulation in this context. The professional challenge is to implement a solution that minimizes downtime, data loss, and resource contention, while meeting recovery point objectives, RPO, and recovery time objectives, RTO. Correct approach analysis. The correct approach involves leveraging DB2 built-in features for efficient and consistent backups, specifically focusing on incremental and cumulative backups combined with archive logging. This strategy allows for granular recovery points, minimizing the amount of data that needs to be reprocessed in case of failure. By performing regular full backups and then supplementing them with frequent incremental or cumulative backups, the DBA can significantly reduce the time and resources required for backup operations. Archive logging ensures that all transactions are captured, enabling point-in-time recovery. This approach aligns with best practices for data availability and integrity, as outlined in DB2 documentation and general database administration principles. Directly addresses the RPO and RTO requirements by providing a mechanism for rapid restoration to a recent state. Incorrect approach is analysis. An approach that relies solely on full backups without incorporating incremental or cumulative backups is inefficient and resource-intensive. Performing frequent full backups can lead to excessive storage consumption and prolonged backup windows, potentially impacting production system performance and availability. This violates the principle of optimizing resource utilization and can be seen as a failure to adhere to best practices for efficient data management. Another incorrect approach would be to neglect archive logging or to perform backups without ensuring that archive logs are properly managed and retained. Without complete archive logs, point-in-time recovery is impossible, and the DBA would be limited to restoring to the last full or incremental backup, potentially resulting in significant data loss. This directly compromises the integrity of the recovery process and fails to meet essential data protection requirements. A third incorrect approach might involve using inconsistent backup methods or failing to regularly test the restore process. Inconsistent backup strategies can lead to corrupted backups or an inability to successfully restore data, rendering the entire backup effort futile. The failure to test restores is a critical oversight that undermines the confidence in the disaster recovery plan and represents a significant professional failing in ensuring data recoverability. Professional reasoning. Professionals should approach this scenario by first understanding the specific RPO and RTO requirements for the critical databases. This involves consulting with stakeholders and business units. Next, they should evaluate DB2 backup and recovery features, considering the trade-offs between different backup types, full, incremental, cumulative, and their impact on system performance, storage, and recovery speed. A robust strategy will typically involve a combination of full backups at defined frequency, followed by more frequent incremental or cumulative backups. Crucially, archive logging must be enabled and properly configured, with a clear strategy for managing and retaining archive logs. Finally, a comprehensive disaster recovery plan must include regular, documented testing of the restore process to validate its effectiveness and ensure that the DBA team is proficient in executing it. This systematic approach ensures that data protection measures are both technically sound and operationally viable. Question 8. The evaluation methodology shows a scenario where a DB2 database administrator is tasked with addressing reported performance degradation in a high-volume transactional system. The DBA has observed a spike in CPU utilization on the database server during specific periods. Considering the need for a robust and reliable database environment, which of the following approaches best aligns with professional best practices for diagnosing and resolving such performance issues? Option A. Immediately adjust database configuration parameters like buffer pool sizes and sort heap sizes based on the observed CPU spike, without further investigation into the specific queries or application behavior causing the load. Option B. Implement significant changes to the database schema or indexing strategy during peak business hours to attempt to alleviate the CPU pressure without prior testing or rollback planning. Option C. Initiate a comprehensive performance analysis, including reviewing database logs, system monitoring tools, and application workload patterns, to identify the root cause of the CPU spike before implementing any tuning changes. Option D. Rely solely on the automated database advisor features within DB2 to suggest and apply configuration changes, assuming the tool will identify and resolve the performance bottleneck. The correct answer is A. Immediately adjust database configuration parameters like buffer pool sizes and sort heap sizes based on the observed CPU spike, without further investigation into the specific queries or application behavior causing the load. Explanation. The evaluation methodology shows a scenario where a DBA is tasked with optimizing database performance for a critical financial application. This scenario is professionally challenging because it requires balancing immediate performance gains with long-term system stability, data integrity, and adherence to strict operational guidelines. The DBA must consider the potential impact of any changes on transaction processing, data consistency, and compliance with internal policies and potentially external regulations, though this question focuses on internal best practices within the DB2 framework. The correct approach represents best professional practice because it prioritizes a systematic, controlled, and well-documented method for performance tuning. This involves thorough analysis of current performance metrics, identification of specific bottlenecks, and the implementation of targeted changes with rigorous testing and rollback plans. This methodical approach minimizes risk, ensures accountability, and aligns with the principles of sound database administration, which are implicitly supported by the operational guidelines and best practices inherent in managing complex database systems like DB2 1. It demonstrates a commitment to maintaining a robust and reliable system. An incorrect approach that involves making immediate, undocumented changes based on anecdotal evidence or a single observed metric is professionally unacceptable. This bypasses essential diagnostic steps and introduces significant risk. Such an approach could lead to unintended consequences, such as data corruption, system instability, or performance degradation in other areas, without a clear understanding of the root cause, violates the principle of due diligence, and can result in significant operational disruption and potential financial loss. Another incorrect approach, such as relying solely on automated tuning tools without expert human oversight and validation, is also professionally deficient. While automated tools can be valuable, they may not always grasp the nuances of a specific application's workload or business criticality. Over-reliance on automation without understanding the underlying logic or potential side effects can lead to suboptimal configurations or even system failures. This approach neglects the DBA's responsibility for informed decision-making and risk management. A third incorrect approach, which involves implementing changes during peak operational hours without proper planning or communication, is a direct contravention of standard operational procedures and risk management principles. This significantly increases the likelihood of impacting live transactions and causing service interruptions. Professional decision-making in such situations requires a structured process. First, clearly define the problem and its impact. Second, gather and analyze relevant data. Third, develop and evaluate potential solutions, considering risks and benefits. Fourth, plan and execute the chosen solution with appropriate controls and rollback mechanisms. And finally, monitor and document the results. Question 9. Consider a scenario where a critical DB2 one database on a Linux server experiences a sudden and complete failure of its primary storage subsystem, leading to an immediate outage. The DBA has access to recent full backups and a continuous stream of transaction logs. Which recovery strategy best ensures data integrity and minimizes data loss while adhering to typical data availability expectations for a production database? Option A. Attempt to bring the database online immediately after the storage subsystem is repaired, assuming the data on disk is still intact. Option B. Restore the database from the most recent full backup and then apply all subsequent transaction logs up to the point of failure. Option C. Restore the database from the most recent full backup and apply only a subset of the transaction logs to expedite recovery. Option D. Rebuild the database from scratch using application-level data replication, bypassing DB2 native recovery mechanisms. The correct answer is B. Restore the database from the most recent full backup and then apply all subsequent transaction logs up to the point of failure. Explanation. This scenario presents a professional challenge in managing data integrity and availability within a DB2 one environment on Linux/Unix/Windows, specifically concerning the impact of storage subsystem failures on critical database operations. The DBA must balance the need for immediate recovery with the long-term implications of data corruption and the potential for regulatory noncompliance if data is lost or inaccessible beyond defined RTO/RPO objectives. The core difficulty lies in selecting a recovery strategy that is both technically sound and adheres to the implicit or explicit service level agreements and data retention policies that govern the database's use. The correct approach, which involves restoring from a consistent backup and then applying transaction logs, represents best professional practice because it guarantees data consistency up to the point of the last successfully applied log. This method directly addresses the potential for data loss and corruption inherent in storage failures by reverting to a known good state and replaying subsequent transactions. This aligns with general data management best practices and, by extension, regulatory expectations for data availability and integrity, ensuring that the database can be restored within acceptable recovery time objectives, RTO, and recovery point objectives, RPO. While the exam syllabus for C2090-614 does not specify a particular jurisdiction's regulations, the principles of data integrity and availability are universally recognized in IT governance and compliance frameworks. An incorrect approach that involves attempting to bring the database online immediately without a full restore and log application, assuming the storage subsystem is repaired, is professionally unacceptable. This is because it carries a high risk of data inconsistency and corruption. If the storage failure caused even minor data corruption that was not detected during the repair, or if transactions were partially written and then lost, the database could be left in an unstable state. This could lead to application errors, incorrect reporting, and potential data loss that violates data integrity principles. Ethically, this approach prioritizes speed over reliability, potentially exposing the organization to significant business and reputational damage. Another incorrect approach, such as restoring from a backup but not applying all available transaction logs, would also be professionally unacceptable. While it might bring the database online faster than a full log application, it would result in data loss for transactions that occurred after the backup was taken and before the point to which logs were applied. This directly violates RPO objectives and can lead to significant business disruption and financial loss, as critical business data would be missing. This failure to meet data availability and integrity standards would be a significant ethical and professional lapse. The professional decision-making process for similar situations should involve a thorough assessment of the failure's impact, the available recovery options, and the defined RTO/RPO. This includes understanding the nature of the storage failure, the type of backup available, e.g., full, incremental, and the status of transaction logs. The DBA should consult relevant documentation, service-level agreements, and potentially business stakeholders to determine the acceptable level of data loss and downtime. Prioritizing a recovery strategy that ensures data consistency and meets RTO/RPO, even if it requires more time, is paramount. This systematic approach, focusing on data integrity and availability, is the cornerstone of professional DBA practice. Question 10. The investigation demonstrates that a critical DB2 database on a Linux system is experiencing intermittent application errors, and diagnostic logs indicate potential data corruption within specific table spaces. The primary goal is to restore data integrity and minimize downtime, while ensuring that the recovery process is auditable and compliant with data management best practices. Which of the following actions represents the most professional and compliant approach to address this data corruption scenario? Option A. Restart the DB2 instance and the affected applications, hoping that the corruption was a transient issue that will resolve itself with a fresh start. Option B. Attempt to manually edit the corrupted data pages using low-level utilities to correct the inconsistencies, assuming this will be faster than a full restore. Option C. Immediately restore the most recent full backup of the affected table spaces to overwrite the corrupted data, then restart the database to resume operations. Option D. Isolate the affected table spaces, perform a point-in-time recovery to a known good state prior to the suspected corruption, and then meticulously verify the integrity of the recovered data before bringing the table spaces back online. The correct answer is C. Immediately restore the most recent full backup of the affected table spaces to overwrite the corrupted data, then restart the database to resume operations. Explanation. The investigation demonstrates a critical scenario involving data integrity and recovery within a DB2 environment on Linux. The professional challenge lies in balancing the immediate need for data availability with the long-term implications of data corruption and the regulatory requirements for data accuracy and auditability. A DBA must make a swift yet informed decision that minimizes data loss while adhering to established best practices and potential compliance mandates. The correct approach represents best professional practice because it prioritizes a systematic and controlled recovery process. By first isolating the affected data and then performing a point-in-time recovery to a known good state, the DBA ensures that the recovered data is consistent and free from the corruption. This method directly addresses the integrity issue without introducing further risk. Furthermore, it aligns with the principle of maintaining an auditable trail of recovery operations, which is often a regulatory requirement for data management. Documenting the cause of corruption and the recovery steps is crucial for future analysis and compliance. An incorrect approach that involves immediately attempting to overwrite the corrupted data with a recent backup without thorough analysis fails to address the root cause of the corruption. This could lead to the reintroduction of the same corruption or the loss of valid transactions that occurred after the backup was taken. From a regulatory perspective, this could be seen as a failure to maintain data integrity and could violate data governance policies that mandate accurate and complete data records. Another incorrect approach, such as attempting to manually edit the corrupted data pages, is highly risky and unprofessional. This method is prone to introducing further inconsistencies and is virtually impossible to audit effectively. It bypasses the built-in integrity checks of DB2 and could lead to unrecoverable states, violating principles of data reliability and potentially breaching regulations that require data to be managed in a controlled and verifiable manner. A further incorrect approach, which is to simply restart the database and hope the issue resolves itself. Ignores the fundamental problem of data corruption. This is a passive and reactive stance that does not address the underlying issue and could lead to continued data degradation or application failures. It demonstrates a lack of due diligence and a failure to uphold the professional responsibility of ensuring data availability and integrity, which could have significant compliance implications if data accuracy is compromised. The professional reasoning process for similar situations should involve a structured approach. 1. Assess the immediate impact and scope of the corruption. 2. Consult available logs and diagnostic tools to understand the nature and potential cause of the corruption. 3. Evaluate recovery options, considering point-in-time recovery, full backups, and potential data loss tolerance. 4. Prioritize data integrity and consistency in the chosen recovery strategy. 5. Document all actions taken, including the cause, recovery steps, and verification procedures. 6. Communicate the situation and recovery progress to relevant stakeholders. 7. Implement measures to prevent recurrence based on the root cause analysis. Question 11. Upon reviewing the performance metrics for a critical DB2 database on a Linux production system, you identify a significant degradation in query response times that is impacting user productivity and potentially revenue. You have identified a potential solution involving a specific index reorganization strategy and parameter tuning. Given the urgency and the potential business impact, what is the most professional and compliant approach to implement this solution? Option A. Implement the index reorganization and parameter tuning on a development server, verify the performance improvement there, and then proceed with the production implementation without a formal rollback plan due to the time constraints. Option B. Develop a detailed rollback plan. Thoroughly test the proposed index reorganization and parameter tuning in a staging environment that mirrors production, and then schedule the implementation during a planned, low-impact maintenance window. Option C. Apply the index reorganization and parameter tuning to the production database without extensive testing, assuming the identified solution is correct and the risk of failure is minimal given the urgency. Option D. Immediately implement the index reorganization and parameter tuning directly on the production database during business hours to resolve the performance issue as quickly as possible. The correct answer is D. Immediately implement the index reorganization and parameter tuning directly on the production database during business hours to resolve the performance issue as quickly as possible. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, balancing performance optimization with data integrity and availability during a critical business period. The pressure to resolve a performance degradation quickly, coupled with the potential impact on revenue-generating applications, necessitates a methodical and risk-aware approach. The DBA must consider not only the technical feasibility of a solution, but also its broader implications for the business and adherence to established operational procedures. Correct approach analysis. The correct approach involves a phased, controlled implementation of the proposed solution. This begins with thorough testing in a non-production environment that closely mirrors the production setup. This allows for validation of the solution's effectiveness and identification of any unintended side effects without risking production systems. Following successful testing, a rollback plan is crucial. This plan details the steps to revert to the previous state if the implemented solution causes issues, minimizing downtime and data loss. Finally, the change is scheduled during a low-impact maintenance window, adhering to change management policies and minimizing disruption to business operations. This methodical process ensures that performance improvements are achieved while maintaining system stability, data integrity, and compliance with operational best practices, which are implicitly governed by internal IT policies and potentially by broader data governance frameworks that emphasize controlled change and risk mitigation. Incorrect approach is analysis. Implementing the solution directly in the production environment without prior testing is a significant regulatory and ethical failure. It violates principles of due diligence and risk management, potentially leading to data corruption, extended downtime, and financial losses. This approach disregards established IT governance and change management protocols, which are designed to prevent such catastrophic failures. Applying the solution without a documented rollback plan is equally problematic. It demonstrates a lack of foresight and preparedness, failing to account for potential adverse outcomes. If the solution fails, the inability to quickly restore service constitutes a breach of service level agreements, SLAs, and can have severe business and reputational consequences. This also indicates a failure to adhere to disaster recovery and business continuity planning principles. Performing the implementation during peak business hours, even with testing, is a failure to respect operational constraints and business continuity. It unnecessarily exposes critical business functions to risk, potentially impacting revenue and customer satisfaction. This demonstrates a lack of understanding of the business impact of IT operations and a disregard for change management policies that mandate minimizing operational disruption. Professional reasoning. Professionals in this role must adopt a risk-based decision-making framework. This involves 1. Understanding the business impact of the problem and any proposed solution. 2. Thoroughly evaluating technical options, including their potential risks and benefits. 3. Prioritizing testing and validation in environments that accurately reflect production. 4. Developing comprehensive rollback and contingency plans. 5. Adhering strictly to change management and operational procedures, including scheduling changes during approved maintenance windows. 6. Communicating effectively with stakeholders about planned changes and potential impacts. This systematic approach ensures that technical solutions are implemented responsibly, safeguarding data integrity, system availability, and business operations. Question 12. Strategic planning requires a DB2 advanced DBA to address a critical performance bottleneck in a high-volume transactional database. The DBA has identified that certain complex queries are significantly impacting response times. Before implementing any changes, what is the most prudent and professionally responsible course of action to ensure both performance gains and adherence to data integrity and regulatory mandates? Option A. Conduct a comprehensive analysis of query execution plans, application access patterns, and data dependencies to identify the root cause of the performance issue, and then design and test targeted optimization strategies with a rollback plan. Option B. Apply universal optimizer hints to all identified slow queries to force a more efficient execution plan. Option C. Immediately implement aggressive indexing strategies on all tables involved in the slow queries to reduce query execution time. Option D. Focus solely on increasing hardware resources, such as CPU and memory, to absorb the performance demands without altering the database schema or queries. Correct answer is A. Conduct a comprehensive analysis of query execution plans, application access patterns, and data dependencies to identify the root cause of the performance issue, and then design and test targeted optimization strategies with a rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, balancing performance optimization with data integrity and regulatory compliance. The pressure to deliver rapid performance improvements without compromising data accuracy or violating data privacy regulations, as mandated by relevant U.S. frameworks like HIPAA for healthcare data or SOX for financial data, depending on the specific industry context of the DB2 deployment, creates a complex decision-making environment. The DBA must consider not only technical feasibility, but also the legal and ethical implications of their actions. Correct approach analysis. The correct approach prioritizes a thorough understanding of the application's data access patterns and the underlying data structures before implementing any performance tuning. This involves detailed analysis of query execution plans, identifying bottlenecks through monitoring tools, and understanding the business criticality of the data. Implementing changes in a controlled, phased manner with robust testing and rollback plans ensures that performance gains are achieved without introducing data corruption or violating compliance requirements. This aligns with best professional practices for database management, emphasizing a systematic and risk-aware methodology. Specifically, it adheres to principles of data governance and security, ensuring that any modifications are auditable and do not inadvertently expose sensitive information or lead to data loss, which would have significant regulatory repercussions. Incorrect approach is analysis. Implementing aggressive indexing strategies without understanding their impact on right operations or data integrity is a significant regulatory and ethical failure. Such an approach could lead to data corruption or performance degradation in transactional workloads, potentially violating service-level agreements and data accuracy mandates. Furthermore, it bypasses the necessary due diligence required by data governance policies. Applying a one-size-fits-all approach to query optimization, such as universally enabling certain optimizer hints or altering configuration parameters without specific analysis, is also professionally unacceptable. This can lead to unintended consequences, such as increased resource consumption, incorrect query results, or performance degradation for critical applications. It demonstrates a lack of understanding of the specific workload and data characteristics, which is a failure in professional diligence and could lead to breaches of data integrity or availability, impacting compliance. Ignoring the potential impact of performance tuning on data privacy and security is a critical regulatory and ethical failure. For instance, certain optimization techniques might inadvertently expose sensitive data or weaken existing security controls, leading to violations of privacy laws. This demonstrates a disregard for the fundamental principles of data protection and responsible data stewardship. Professional reasoning. Professionals should adopt a structured analytical approach. This involves 1. Understanding the business context and regulatory landscape. 2. Thoroughly analyzing the current system performance and identifying specific problem areas. 3. Developing a hypothesis for potential solutions, considering all technical, performance, and compliance implications. 4. Implementing solutions in a controlled environment with rigorous testing and validation. 5. Monitoring the impact of changes and having a rollback strategy. This systematic process minimizes risk and ensures that decisions are informed, defensible, and aligned with professional and regulatory standards. Question 13. Examination of the data shows a significant increase in query response times across several critical applications, impacting user productivity. Initial monitoring indicates high CPU utilization on the DB2 server, but the specific queries or processes responsible are not immediately obvious. The DBA needs to address this performance degradation promptly while adhering to established operational procedures for system changes. Option A. Conduct a detailed analysis of the current workload, identifying the top resource-consuming queries and their execution plans. Based on this analysis, propose and document specific, targeted optimizations or index additions, and then implement them during a scheduled maintenance window after obtaining necessary approvals. Option B. Immediately restart the DB2 instance to clear any potential transient issues and observe if performance returns to normal. Option C. Apply a broad, system-wide performance tuning parameter change that is known to improve general DB2 performance without first analyzing the specific workload. Option D. Advise the application teams to reduce their query load temporarily until the performance issue can be investigated further. The correct answer is A. Conduct a detailed analysis of the current workload, identifying the top resource-consuming queries and their execution plans. Based on this analysis, propose and document specific, targeted optimizations or index additions, and then implement them during a scheduled maintenance window after obtaining necessary approvals. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, ensuring data integrity and availability while adhering to strict operational procedures and potential regulatory compliance requirements. The core difficulty lies in balancing the immediate need to resolve a performance issue with the established protocols for system changes, especially when those protocols are designed to prevent unintended consequences and maintain auditability. The DBA must quickly diagnose the root cause of the performance degradation without introducing further risk or violating established change management policies. Correct approach analysis. The correct approach involves a systematic, documented investigation that prioritizes understanding the impact of any proposed changes. This aligns with best professional practices for database administration, which emphasize a controlled and auditable approach to system modifications. Specifically, it adheres to the implicit regulatory framework of maintaining system integrity and operational continuity, which are often mandated by industry standards and internal governance. By first analyzing the existing workload and identifying the specific queries causing the bottleneck, the DBA can then propose targeted, low-risk solutions. Documenting this analysis and the proposed solution before implementation is crucial for accountability and for future troubleshooting. This methodical process minimizes the risk of introducing new problems and ensures that any changes are justifiable and traceable. Incorrect approach is analysis. Implementing a broad, undocumented change without thorough analysis is a significant regulatory and ethical failure. Such an action bypasses established change control procedures, which are often in place to comply with internal audit requirements and external regulations concerning data security and system stability. This lack of documentation makes it impossible to trace the cause of future issues and demonstrates a disregard for operational discipline. Applying a generic performance tuning technique without understanding its specific impact on the current workload is also professionally unsound. While the technique might be valid in other contexts, its application here could exacerbate the problem or negatively affect other critical processes. This demonstrates a lack of deep analytical skill and a failure to exercise due diligence, potentially leading to service disruption and non-compliance with service-level agreements. Ignoring the performance issue and hoping it resolves itself is a dereliction of duty. This approach not only fails to address the immediate problem, but also risks escalating it, potentially leading to data corruption, extended downtime, and significant business impact. This inaction violates the professional obligation to maintain system health and availability. Professional reasoning. Professionals should approach performance issues with a structured methodology. This involves 1. Problem identification. Clearly define the observed symptoms. 2. Data collection. Gather relevant performance metrics and system logs. 3. Root cause analysis. Systematically investigate potential causes, prioritizing those with the highest probability. 4. Solution design. Develop targeted solutions based on the analysis, considering their potential impact and rollback strategies. 5. Implementation. Execute changes following established change management procedures with proper documentation and testing. 6. Verification. Monitor the system post-implementation to confirm the issue is resolved and no new problems have arisen. This framework ensures that actions are informed, controlled, and defensible. Question 14. Performance analysis shows that a critical application is experiencing intermittent but significant slowdowns, particularly during peak usage hours. The DB2 one database server on Linux is showing high CPU utilization and increased disk I/O wait times. The DBA suspects a performance bottleneck within the database, but needs to pinpoint the exact cause before making any configuration changes. Which of the following diagnostic approaches is most likely to lead to an accurate and efficient resolution? Option A. Analyze the output of the DB2 snapshot monitor for the application's workload, focusing on metrics like buffer pool hit ratios, lock weights, and the execution of specific SQL statements, and then examine the explain plans for the longest-running or most frequently executed queries. Option B. Immediately increase the size of all buffer pools and log buffer to their maximum allowed values to ensure sufficient memory allocation. Option C. Advise the application development team to rewrite all SQL queries to be simpler, assuming that complex queries are the sole cause of the performance degradation. Option D. Restart the DB2 instance and the Linux operating system to clear any potential transient issues and observe if performance improves. The correct answer is B. Immediately increase the size of all buffer pools and log buffer to their maximum allowed values to ensure sufficient memory allocation. Explanation. This scenario presents a common challenge for DB2 advanced DBAs, identifying and resolving performance bottlenecks that impact application responsiveness and user experience. The professional challenge lies in accurately diagnosing the root cause of the performance degradation without disrupting ongoing operations or making assumptions that could lead to incorrect tuning. The DBA must balance the need for immediate resolution with the requirement to maintain data integrity and system stability. The correct approach involves a systematic and data-driven investigation. This includes leveraging DB2 built-in monitoring tools and diagnostic utilities to gather detailed information about the workload, resource utilization, and specific SQL statements contributing to the performance issue. Analyzing metrics such as buffer pool hit ratios, lock weights, I/O activity, and query execution plans is crucial. This methodical approach ensures that tuning efforts are targeted and effective, minimizing the risk of introducing new problems. It aligns with best professional practices by prioritizing accurate diagnosis before implementing solutions, thereby ensuring optimal system performance and resource utilization. An incorrect approach would be to immediately implement broad, unverified tuning parameters without a clear understanding of their impact. For instance, arbitrarily increasing buffer pool sizes without analyzing current usage patterns might lead to excessive memory consumption and reduced overall system efficiency. Another incorrect approach would be to focus solely on application-level changes without considering the underlying database configuration. This could result in wasted development effort if the bottleneck is fundamentally a database performance issue. A third incorrect approach might be to rely on anecdotal evidence or past experiences without validating them with current system data, potentially leading to misdiagnosis and ineffective solutions. These approaches fail to adhere to professional standards by bypassing rigorous analysis and potentially causing unintended negative consequences. Professionals should employ a structured decision-making process. 1. Define the problem clearly. What specific performance issue is being observed? 2. Gather data. Utilize monitoring tools and diagnostic logs to collect relevant metrics. 3. Analyze data. Correlate observed symptoms with system behavior and resource utilization. 4. Formulate hypotheses. Based on the analysis, propose potential root causes. 5. Test hypotheses. Implement targeted changes or further investigations to validate hypotheses. 6. Implement solutions. Apply tuning or configuration changes based on validated hypotheses. 7. Monitor and verify. Continuously monitor the system to confirm the effectiveness of the solution and prevent recurrence. Question 15. The risk matrix shows a high probability of database corruption impacting critical financial transaction data. The primary recovery objective is to restore the database to a state that is both consistent and as close to the point of failure as possible, while adhering to established data integrity protocols. The last successful full backup was taken 7 days ago. Incremental backups have been performed daily since then. Differential backup was taken 24 hours ago. The transaction logs are backed up every 15 minutes. The database is currently inaccessible due to suspected data file corruption. What is the most appropriate recovery strategy to ensure data integrity and minimize data loss? Option A. Restore the most recent full backup and the differential backup taken 24 hours ago, then attempt to manually repair any remaining inconsistencies. Option B. Restore the most recent full backup and then immediately attempt to bring the database online without applying subsequent backups to expedite service restoration. Option C. Restore only the differential backup taken 24 hours ago, assuming it contains all necessary recent changes. Option D. Restore the most recent full backup, followed by all subsequent incremental backups in order, and then apply the transaction log backups up to the point of failure. The correct answer is D. Restore the most recent full backup, followed by all subsequent incremental backups in order, and then apply the transaction log backups up to the point of failure. Explanation. Scenario analysis. This scenario presents a professional challenge due to the critical nature of data integrity and the potential for significant business disruption if a database corruption event occurs. The DBA must balance the need for rapid recovery with the imperative to maintain data consistency and adhere to established recovery procedures. The pressure to restore service quickly can lead to shortcuts that compromise long-term data health and regulatory compliance. Careful judgment is required to select a recovery strategy that minimizes downtime without introducing new risks. Correct approach analysis. The correct approach prioritizes a consistent and validated recovery process, restoring from the most recent full backup, and then applying incremental and differential backups in the correct sequence ensures that the database is brought to a known, consistent state. This method, when combined with transaction log backups, allows for point-in-time recovery, which is crucial for meeting data integrity requirements and potentially regulatory audit demands. This approach represents best professional practice because it systematically rebuilds the database, minimizing the risk of data loss or corruption that could arise from incomplete or improperly applied recovery steps. It aligns with the principle of least privilege and controlled change management, essential for maintaining a stable and compliant database environment. Incorrect approaches analysis. One incorrect approach involves attempting to restore only the most recent differential backup without considering the preceding full and incremental backups. This would likely result in an inconsistent database state, as the differential backup only captures changes since the last full or incremental backup. This failure to follow a complete recovery sequence directly violates data integrity principles and could lead to application errors or data corruption, posing a significant risk to business operations and potentially violating data protection regulations if sensitive information becomes compromised or inaccessible. Another incorrect approach is to bypass the backup and recovery process entirely and attempt to manually repair the corrupted data files. While this might seem like a faster solution in the short term, it is highly risky. Manual data repair is prone to errors, can introduce further corruption, and offers no guarantee of data consistency. This approach disregards established recovery procedures and best practices, increasing the likelihood of permanent data loss and failing to meet the auditability and recoverability requirements mandated by many regulatory frameworks. It also bypasses the controlled and tested nature of backup restoration, which is a cornerstone of disaster recovery and business continuity planning. Professional reasoning. Professionals should approach such situations by first assessing the extent of the corruption and the available recovery points. The decision-making process should involve consulting the organization's documented disaster recovery and business continuity plans, prioritizing data integrity and consistency over immediate, potentially risky, speed is paramount. This involves a systematic approach to restoration, starting with the most recent valid full backup and progressing through incremental and differential backups, followed by transaction logs, if applicable. Communication with stakeholders regarding the recovery timeline and potential impact is also critical. Professionals should always adhere to established procedures and seek expert consultation if the situation exceeds their immediate expertise, ensuring that all actions are auditable and defensible. Question 16. Analysis of a critical DB2 one database on a Linux system experiencing unexpected data corruption in a key table. The database is subject to industry regulations requiring strict data integrity and auditable recovery processes. The immediate business impact is significant, with critical applications unable to access essential data. The DBA has access to recent transaction logs and a recent full backup. What is the most professional and compliant approach to restore data integrity and service availability? Option A. Manually edit or delete the corrupted data files directly on the file system to remove the problematic data, then restart the database. Option B. Utilize DB2 roll-forward recovery mechanism, applying transaction logs to the most recent consistent point before the corruption, while meticulously documenting each step and the findings from log analysis. Option C. Immediately restore the database from the most recent full backup, overriding the corrupted data without further investigation into the corruption's cause. Option D. Advise stakeholders to temporarily avoid the corrupted table and hope the issue resolves itself over time. The correct answer is B. Utilize DB2 roll-forward recovery mechanism, applying transaction logs to the most recent consistent point before the corruption, while meticulously documenting each step and the findings from log analysis. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, ensuring data integrity and availability while adhering to strict operational procedures and potential regulatory compliance requirements. The core difficulty lies in balancing the immediate need for system recovery with the imperative to maintain audit trails and prevent unauthorized data modification. The DBA must act decisively but also meticulously, considering the downstream impact of their actions on data governance and security. The pressure to restore service quickly can lead to shortcuts that compromise these critical aspects. Correct approach analysis. The correct approach involves leveraging DB2 built-in auditing and logging mechanisms to reconstruct the sequence of events leading to the corruption. This aligns with best professional practices for data recovery and incident response. Specifically, using DB2 recovery tools in conjunction with the transaction logs, e.g., roll-forward recovery, allows for a controlled restoration of the database to a consistent state prior to the corruption. This method preserves the audit trail, demonstrating due diligence and compliance with data integrity principles. It also minimizes the risk of introducing further inconsistencies or data loss by relying on established, documented recovery procedures. This approach is crucial for meeting potential regulatory mandates that require accurate historical data and auditable recovery processes. Incorrect approach is analysis, manually attempting to edit or delete corrupted data files without a clear understanding of the underlying database structure, and without utilizing DB2 recovery utilities is a significant regulatory and ethical failure. This approach bypasses the database's internal consistency checks and transaction management, leading to data corruption that is likely unrecoverable by standard means. It also destroys the audit trail, making it impossible to determine the cause of the corruption or the extent of any manual intervention, which would be a direct violation of data integrity and auditability requirements. Restoring from a backup without first attempting a log-based recovery or without thoroughly investigating the cause of the corruption is also problematic. While restoring from backup is a valid recovery strategy, doing so prematurely can result in data loss if recent transactions are not captured in the backup. Furthermore, it fails to address the root cause of the corruption, meaning the issue could recur. This approach neglects the principle of root cause analysis in incident management and can be seen as a failure to maintain data currency and completeness, potentially violating data governance policies. Ignoring the corruption and hoping it resolves itself or does not impact critical operations is the most severe failure. This demonstrates a complete disregard for data integrity, availability, and potential regulatory compliance. It exposes the organization to significant risks, including data loss, operational disruption, and legal repercussions for failing to safeguard data. This approach is fundamentally unethical and unprofessional. Professional reasoning. Professionals facing such a situation should follow a structured incident response plan. This typically involves 1. Containment, preventing further damage or spread of the corruption. 2. Diagnosis, thoroughly investigating the cause of the corruption using available logs and diagnostic tools. 3. Recovery, implementing the most appropriate recovery strategy, prioritizing data integrity and auditability. 4. Resolution, addressing the root cause to prevent recurrence. 5. Documentation, meticulously recording all actions taken, findings, and outcomes for audit and future reference. This systematic approach ensures that decisions are informed, defensible, and aligned with both technical best practices and regulatory expectations. Question 17. The performance metrics show a significant increase in I/O wait times and disk utilization on a DB2 one database, impacting application response times. The database contains historical transaction data that is subject to a mandatory 7-year retention period as per financial industry regulations. The DBA is considering several strategies to alleviate the performance bottleneck. Which of the following strategies best balances performance improvement with regulatory compliance? Option A. Implement a data compression technique on all tables, including historical data, without first verifying if the compression method affects the auditability or integrity of the data for regulatory review. Option B. Aggressively purge all transaction data older than 3 years to reduce the database size and I/O load, assuming that most historical data is no longer actively used. Option C. Disable detailed transaction logging for all but the most recent 6 months of data to reduce write I/O, as the primary goal is to improve current transaction throughput. Option D. Implement a robust data archiving strategy that moves older, less frequently accessed data to a separate storage tier, ensuring that the archived data remains accessible for audit purposes and adheres to the 7-year retention policy. Correct answer is D. Implement a robust data archiving strategy that moves older, less frequently accessed data to a separate storage tier, ensuring that the archived data remains accessible for audit purposes and adheres to the 7-year retention policy. Explanation. This scenario presents a common challenge for DB2 advanced DBAs, balancing system performance with the strict requirements of regulatory compliance, specifically concerning data retention and auditability. The challenge lies in interpreting performance metrics in the context of legal and regulatory obligations, ensuring that actions taken to improve performance do not inadvertently compromise compliance. The correct approach represents best professional practice because it prioritizes a thorough understanding of the regulatory framework before implementing any technical solutions. In the context of the C2090-614 exam, which focuses on DB2 one for Linux, UNIX, and Windows, regulatory compliance often involves adherence to data privacy laws, industry-specific regulations, and internal corporate policies that dictate how data is stored, accessed, and retained. A DBA must ensure that any performance tuning activities, such as archiving or purging old data, are executed in a manner that respects these regulations. This includes verifying that data is not deleted prematurely, that audit trails are maintained, and that data access controls remain robust. The correct approach demonstrates a commitment to both operational efficiency and legal/ethical responsibilities, which is paramount for maintaining data integrity and avoiding legal repercussions. An incorrect approach that focuses solely on aggressive data purging without verifying its compliance with data retention policies would represent a significant regulatory failure. This could lead to the premature deletion of data that is legally required to be retained for a specific period, resulting in fines, legal action, and reputational damage. Another incorrect approach, such as disabling detailed logging to reduce I/O overhead, would fail to meet auditability requirements. Regulators often mandate comprehensive audit logs to track data access and modifications, and disabling these logs would make it impossible to demonstrate compliance or investigate security incidents. A third incorrect approach, like implementing a performance solution that inadvertently grants broader data access than permitted by privacy regulations, would violate data privacy laws, leading to severe penalties. The professional decision-making process for similar situations should involve a multi-step approach. 1. Understand the regulatory landscape. Before any performance tuning, thoroughly review all applicable regulations, laws, and internal policies related to data retention, privacy, and auditability. 2. Analyze performance metrics in context. Interpret performance metrics not just from a technical standpoint, but also through the lens of compliance. For example, high I/O might be due to necessary audit logging. 3. Consult with legal and compliance teams. If there is any ambiguity regarding regulatory requirements or the impact of proposed solutions, engage with legal counsel and compliance officers. 4. Develop compliance solutions. Design and implement performance tuning strategies that explicitly address and satisfy all regulatory mandates. This might involve using specific DB2 features for data archiving, partitioning, or secure deletion that align with retention policies. 5. Test and validate. Rigorously test any implemented solutions to ensure they improve performance without compromising data integrity or compliance. Question 18. The analysis reveals that a critical DB2 database on a Linux production server is experiencing significant performance degradation during peak transaction hours, impacting user productivity and business operations. The DBA team is under pressure to resolve this issue immediately. Several potential solutions are being considered, ranging from aggressive parameter tuning to immediate application of known, best practice configurations. The challenge lies in selecting the most appropriate and least disruptive course of action that ensures both performance improvement and system stability. Option A. Immediately apply a comprehensive set of performance tuning parameters that are widely considered best practices for DB2 1, as these are known to generally improve performance across various workloads. Option B. Implement a single, aggressive parameter change that has been suggested by an external forum post as a quick fix for similar performance issues, without prior testing or verification in a non-production environment. Option C. Conduct a thorough diagnostic analysis using DB2 monitoring tools and system logs to identify the specific bottlenecks. Based on the findings, implement targeted tuning changes in a development or staging environment first, followed by a controlled rollout to production with a defined rollback plan. Option D. Revert to a previous, known stable configuration of the database, and then incrementally reapply recent changes while monitoring performance, even if this means significant downtime. Correct answer is C. Conduct a thorough diagnostic analysis using DB2 monitoring tools and system logs to identify the specific bottlenecks. Based on the findings, implement targeted tuning changes in a development or staging environment first, followed by a controlled rollout to production with a defined rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 advanced DBAs, balancing performance optimization with data integrity and regulatory compliance in a production environment. The pressure to quickly resolve performance degradation, especially during peak business hours, can lead to hasty decisions that overlook critical dependencies or potential side effects. The complexity of DB2 1 on Linux/Unix/Windows, with its intricate configuration parameters and interdependencies, amplifies this challenge. A DBA must not only understand the technical aspects, but also the business impact and the potential for unintended consequences. Correct approach analysis. The correct approach involves a systematic, phased, and documented methodology. This begins with thorough diagnostics to pinpoint the root cause of the performance issue, rather than applying a generic fix. Implementing changes in a controlled manner, such as a development or staging environment first, is crucial for validating their effectiveness and identifying any adverse impacts before affecting production. This aligns with best practices for change management and risk mitigation, which are implicitly supported by general IT governance principles that emphasize minimizing disruption and ensuring system stability. The use of monitoring tools to track performance before, during, and after the change provides objective evidence of the impact and allows for rollback if necessary. This methodical approach ensures that the solution is robust, sustainable, and does not introduce new problems, thereby upholding the DBA's responsibility for system reliability. Incorrect approaches analysis. Applying a broad set of performance tuning parameters without a clear diagnosis is a significant regulatory and ethical failure. It demonstrates a lack of due diligence and a disregard for the principle of least privilege and minimal impact. This approach risks introducing instability, data corruption, or security vulnerabilities by altering system behavior without understanding the specific cause of the problem. It violates the implicit ethical obligation to act in the best interest of the organization by prioritizing speed over accuracy and safety. Furthermore, it could lead to non-compliance with internal IT policies and potentially external regulations if system integrity is compromised. Implementing a single, aggressive tuning parameter change directly in production based on anecdotal evidence or a quick search, without prior testing or rollback planning, is professionally unacceptable. This bypasses essential risk assessment and validation steps. It represents a failure to adhere to established change management protocols, which are designed to protect the integrity and availability of critical systems. Such an action could lead to severe performance degradation, system outages, or data loss, directly impacting business operations and potentially leading to financial or reputational damage. This demonstrates a lack of professional responsibility and a disregard for the potential consequences. Making significant configuration changes without proper documentation or a rollback strategy is a critical failure. Documentation is essential for auditing, knowledge transfer, and future troubleshooting. The absence of a rollback plan means that if the change has negative consequences, there is no immediate way to restore the system to a stable state, leading to prolonged downtime and potential data loss. This directly contravenes the principles of sound system administration and risk management, which are fundamental to maintaining operational integrity and fulfilling the DBA's professional duties. Professional reasoning. Professionals should approach performance issues with a structured problem-solving methodology. This involves 1. Clearly defining the problem and its impact. 2. Gathering comprehensive diagnostic data. 3. Formulating hypotheses about the root cause. 4. Testing hypotheses in a controlled environment. 5. Developing and implementing solutions with a clear rollback plan. 6. Monitoring the results and documenting the entire process. This systematic approach ensures that solutions are effective, efficient, and minimize risk to the production environment, upholding professional standards of care and responsibility. Question 19. Research into the implications of implementing a new data archiving strategy for a DB2 one database on Linux, focusing on ensuring compliance with data retention and privacy regulations applicable within the exam's specified jurisdiction. Option A. Proceed with the archiving strategy immediately to free up production storage, assuming that moving data to an archive automatically satisfies all regulatory requirements. Option B. Implement the archiving strategy after a comprehensive review with legal and compliance teams to ensure all data retention periods and privacy requirements are met, including data minimization and secure deletion of archived data. Option C. Implement the archiving strategy by encrypting the archived data, believing that encryption alone is sufficient to meet all regulatory obligations without further review of retention or access controls. Option D. Archive all historical data without specific consideration for data retention periods, relying on the assumption that older data is less sensitive and therefore less regulated. Correct answer is B. Implement the archiving strategy after a comprehensive review with legal and compliance teams to ensure all data retention periods and privacy requirements are met, including data minimization and secure deletion of archived data. Explanation: this scenario presents a professional challenge due to the critical need to balance operational efficiency with stringent data privacy regulations. The DBA is tasked with optimizing database performance while ensuring compliance with data protection laws, which often impose strict controls on data access, storage, and processing. The challenge lies in identifying and implementing performance enhancements without inadvertently violating these regulations, which could lead to severe legal penalties, reputational damage, and loss of customer trust. Careful judgment is required to understand the nuances of both performance tuning techniques and the specific requirements of the applicable regulatory framework. The correct approach represents best professional practice because it prioritizes a thorough understanding of the regulatory landscape before implementing any technical changes. By consulting with legal and compliance teams, the DBA ensures that proposed performance tuning strategies are reviewed against relevant data protection laws. This proactive engagement allows for the identification of potential compliance risks early in the process and facilitates the development of solutions that are both effective for performance and fully compliant. This aligns with the ethical obligation of a DBA to protect sensitive data and uphold legal requirements. An incorrect approach that involves implementing performance enhancements without prior regulatory review poses significant risks. Such an approach could lead to the accidental exposure or unauthorized processing of sensitive data, directly violating data privacy regulations. For instance, implementing aggressive caching mechanisms without proper data masking or anonymization could inadvertently make personally identifiable information, PI, more accessible. Another failure would be to assume that standard performance tuning practices are inherently compliant, neglecting the specific mandates of the applicable jurisdiction regarding data handling, consent, and data subject rights. This demonstrates a lack of due diligence and a disregard for legal obligations. The professional decision-making process for similar situations should involve a structured risk assessment. First, identify the proposed technical change and its potential impact on data handling. Second, consult the relevant regulatory framework and internal compliance policies to understand specific requirements related to the data being processed. Third, engage with legal and compliance experts to validate the proposed approach. Fourth, document all decisions and justifications, ensuring a clear audit trail. Finally, implement changes with continuous monitoring to ensure ongoing compliance and performance. Question 20. Process analysis reveals that a financial services organization is undergoing a regulatory audit concerning its data handling practices for customer financial information stored in DB2 1. The audit specifically requires evidence of comprehensive data access and modification logging for all sensitive tables. The DBA is considering several strategies to meet this requirement. Which of the following strategies best aligns with regulatory compliance and best professional practice for advanced DB2 administration on Linux/Unix/Windows? Option A. Store audit logs in a readily accessible network share without specific access controls, assuming that only authorized personnel will access them. Option B. Rely solely on general database security settings and user privilege management to satisfy the audit, as detailed data access logging is considered overly burdensome. Option C. Disable auditing on tables that are accessed less frequently, as they are deemed less critical to immediate operational oversight, to reduce the performance overhead of logging. Option D. Implement granular auditing on all tables containing customer financial information, ensuring audit logs are securely stored with restricted access and regularly reviewed for suspicious activity. Correct answer is D. Implement granular auditing on all tables containing customer financial information, ensuring audit logs are securely stored with restricted access and regularly reviewed for suspicious activity. Explanation: this scenario presents a professional challenge because the DBA is tasked with ensuring data integrity and availability while simultaneously adhering to strict regulatory compliance requirements for data handling and auditing. The challenge lies in balancing operational efficiency with the imperative to maintain auditable trails and prevent unauthorized access or modification, especially when dealing with sensitive data that might be subject to specific data privacy regulations. The need for robust security measures and meticulous logging is paramount. The correct approach represents best professional practice because it directly addresses the regulatory mandate for data protection and auditability. By implementing granular auditing on sensitive data tables and ensuring that audit logs are securely stored and regularly reviewed, the DBA is proactively fulfilling compliance obligations. This demonstrates a commitment to data governance, security, and transparency, which are foundational to regulatory frameworks governing data management. The focus on specific tables and the secure, regular review of logs ensures that compliance efforts are targeted, effective, and sustainable. An incorrect approach that involves disabling auditing on less frequently accessed tables, even if deemed less critical by the DBA, represents a significant regulatory and ethical failure. This action creates blind spots in the audit trail, making it impossible to detect or investigate potential data breaches, unauthorized access, or policy violations related to those tables. It directly contravenes the principle of comprehensive data monitoring, required by many regulatory bodies. Another incorrect approach, such as relying solely on database-level security settings without specific data auditing, is also professionally unacceptable. While database security is essential, it does not provide the granular, activity-specific audit information needed to demonstrate compliance with regulations that require tracking who accessed or modified what data, and when. This approach fails to provide the necessary evidence for compliance audits and leaves the organization vulnerable to undetected misuse of data. Finally, an approach that involves storing audit logs in easily accessible locations without proper access controls or retention policies is a critical failure. This exposes sensitive audit information to unauthorized access or tampering, undermining the integrity of the audit trail and violating data protection principles. It also fails to meet regulatory requirements for secure log management and retention. Professional reasoning process for similar situations should involve a thorough understanding of applicable regulatory frameworks, a risk-based assessment of data sensitivity and access patterns, and the implementation of a layered security and auditing strategy. DBAs must prioritize compliance by proactively identifying regulatory requirements, designing auditing mechanisms that meet those requirements, and establishing robust processes for log management, review, and retention. Regular training and awareness of evolving regulations are also crucial.